Hello friends, so in this short video, today we are going to see how cylindrical coordinate system is organized, right? So when you learn the subject electromagnetic field in learning certain concept, instead of the conventional Cartesian XYZ coordinate system, it is advantageous to use the different coordinate system. So in that connection, we are going to discuss over here the cylindrical coordinate system in this short video. Now, the cylindrical coordinate system assumes that any point on in 3 dimension is available on the surface of a cylinder. A cylinder which is having axis as a z-axis. Let's assume this vertical line is a z-axis, and let us say the radius of this cylinder is a rho. So cylinder can have any radius from 0 to say infinite. Let us say rho is the radius. Now this point P is at an angle of phi from the x-axis. So the red line over here, let's see. Yeah. So this is the x-axis, and it is at an angle phi from the this distance is rho, this angle is phi, and then vertically you are going the distance or height of this point from the origin. This point is origin, is z, right? So this point is on cylinder. You can see over here, this point is at a distance rho, and then this is x-axis. Then you turn at an angle phi, and then the height is z. So this is the point P, which is having now coordinates rho, phi, and z. Rho is this distance, which is the radius of the cylinder. Z is the axis. This is the origin point. Phi is the angle in this you can say anti-clockwise direction. You are moving from positive x-axis, and then you move vertically upward along or parallel to z-axis by the amount z. So this are the coordinates: rho, radius of the cylinder; phi, angle it makes with the positive x-axis; and z is the height of that point from the origin, right? So along the z-axis. So this P, rho, phi, and z is now the point in 3 dimension and explained or described in cylindrical coordinate system. So cylindrical coordinate system has three, you can say, coordinates. One is rho, which is radius. It will be in the distance unit. Phi is going to be the angle, so it is going to be in degrees and radians, and z also is a height, so it is also in a distance unit, right? So you can see the rho dimension, it can take from 0 to infinity, cylinder radius. While the angle, you can see you can have angle from 0 to plus 360 degree or minus 360 degree. So phi can be phi can take any value between 0 to 360 degree. It should be less than or equal to. So I hope you understand that. And z can be along positive z-axis, or it can be along negative z-axis. So it can have any number from minus infinity to infinity. So these are the three coordinates. Rho is the radius of cylinder, phi is the angle in radians or degrees, and z is height along the z-axis, right? Now, next is the dimensions which it can take. We have already seen. So let's see the unit vectors. So what are the unit vectors? We know ax, ay, and az are unit vectors along x, y, z axis, along the direction which x dimension increase or y dimension increase or z dimension increases. Now, what are the unit vectors of this cylindrical coordinate system? So this is my cylindrical coordinate system. So these are the unit vectors. Now, what is this A rho? A rho is basically the vector which is unit vector acting away from the center line in the radius. So suppose I draw a radius joining center line to the point P, and if I point it radially outward, that is the direction of A rho. So it is the direction which is indicated in which the radius is increasing, and it is perpendicular to the surface of the sphere, right? Now, A phi is the direction which is in which this is going to increase, right? This is the direction. So A phi is nothing but the unit vector along which the phi increases. So it is at point P tangential to the cylinder, as you can see. And AZ, obviously, it is in the direction of the Z axis. So these are the three unit vectors, and they are mutually also perpendicular to one another. As you can see over here, arrow is perpendicular to Z axis and pointing away. A phi is perpendicular to arrow, and it is tangential to the cylinder. It is acting in such a way that the angle is increasing, and AZ is also along the Z axis, right? So that is how you explain the cylindrical coordinate system, right? So next short video we'll discuss about the spherical coordinate system. So that's all here.